Hey, welcome to 8.2 Notes, Exterior Angles of Polygons. Alright, we're going to start with some review here. Remember the sum of the interior angles, the equation for that? Well, if you don't, I'll tell you what it was. It was 180. Now, why is it 180? Because that's the number of degrees in a triangle, right? And then it was times n, that's the sides, minus 2. And why n minus 2? Because n minus 2 is the number of triangles in any figure. If you have a pentagon with 5 sides, how many triangles are in that pentagon? 3. 5 minus 2, right? And then you just multiply the number of triangles in the figure by 180. Okay. Now, for each interior angle, well, it's just 180 times n minus 2, so that's the sum of all of your interior angles. That's however many interior angles you have. I mean the sum of the degrees for all of your interior angles. But this time, because it's each interior angle, we're going to divide by the sides. Okay, so you're going to have the degrees up top, you're going to have the degrees, and on the bottom you're going to have the number of angles. So you end up with like degrees per angle if you divide by the number of angles. Okay. Well, let's put that into action. Remember, this is just a review of what you guys learned yesterday. What is the sum of interior angles of a convex dodecagon? Do means 2, deca means 10, gon means side, right? So we have 12 sides, right? What is the sum of the interior angles of a convex dodecagon? So we're going to use sum of interior angles. It says that right there. And go ahead and try that now. Remember, it's a 12-sided figure, and you're going to be using this equation. All right. Well, you should have started off with this equation. This equation, 180 degrees times, and then we do dodeca, that's 12 minus 2, equals the sum of the entire interior angles. Well, 12 minus 2, of course, is 10, and 10 times 180 is 1,800 degrees. What's the sum of the interior angles of a convex dodecagon? 1,800 degrees. What is the measure of one of the interior angles of a regular convex dodecagon? Now, this next thing you can only do if it's a regular dodecagon, because each angle is going to be the same. That's important. It's a regular dodecagon, so each angle is going to be the same. Well, I'm going to take my, what I figured out was the sum of the interior angles, and that's going to be 1,800, right? And I got that from this up here. And then I'm going to divide it by the number of sides, or the number of angles, really, in this dodecagon. The number of angles is 12, right? So I'm going to divide it by 12. And so the answer for that is 150 degrees per angle. Remember, there are 12 angles here. All right. Just as a reminder, this is where I got that equation. Okay. The sum of the measure of exterior angles of a convex polygon. And actually, as I look at the stuff, you guys don't have this particular class example in your notes. And so I'm going to show you, you guys have a class activity, and it asks you to take a look at a polygon. It looks like a hexagon there, and then find the exterior angles. So let's take a look at the pictures here. The pictures I have. Now, this is not a hexagon, but it's similar to what you're looking at right there. And let's take a look at what the angles are. So, an exterior angle is the angle that is formed by an extension of one side and then the other side of your polygon here. So, this angle is going to be my interior, right? But this angle is going to be my exterior angle, all right? And that's the same thing here. This is my exterior angle, this is my exterior, this, and this. So all of those are my exterior angles. And also know that my exterior and my interior angles, what do you think they add up to? 180 degrees. Okay? Those guys are actually our supplementary supplementary angles. Alright. But let's look at what each of these angles actually adds up to here. So I'm gonna shrink this little polygon here, and my next picture with my shrunken polygon is the smaller polygon, okay? And as I keep shrinking my polygon, it gets smaller. Now notice that the angles are not changing. The angles are still remaining the same size, all right? The same angles. This one, if this one is 32, it's still going to be 32. This one, same thing. The angles are staying the same angle. It's only the polygon that's shrinking. Now, notice that we've got, it's starting to look like a what? Instead of a polygon, it's starting just to look like a circle, right? Now, I've got my little circle here, and as I shrank the polygon down to a small size, what do we notice about all of these angles when they're added together? Those angles equal a circle. When I shrink that polygon down enough, it just becomes the center of my circle. And all of these angles are going to add up to how many degrees? How many degrees does a circle have? (360 degrees. Therefore, what is the sum of each exterior angle on a polygon? The sum of each exterior angle on a polygon is going to be 360 degrees. Alright, so now we'll go back over here. Now see, we went from a large polygon all the way to, we just shrank it, we kept the angles the same. We saw it was the exterior angles measured up to 360 degrees. So the sum of the exterior angle measures is going to be what? 360 degrees, right? Always. No matter what type of polygon it is, okay? Always. Now, the measure of each exterior angle, well, that's just going to be 360 degrees divided by the number of sides or angles, right? We'll say angles. Basically, remember, however many sides a polygon has, it has the same amount of angles. So, for example, if we're talking about a pentagon with 5 sides, then what is the measure of each exterior angle of a pentagon? We divide 360 by 5 and we get 108 degrees. That'll be the measure of each exterior angle of a pentagon. Now, just so you can see it, I'm going to draw a beautiful pentagon right here. And remember, if I extend each of these sides of the pentagon one way, I've got like a little pinwheel, right? When we're talking about the exterior angles, that's these guys right here. And they add up to 100. They add up to 360. So if it's a regular polygon, if it's a regular pentagon, then those guys add up to 108. Okay. If each exterior angle of a regular polygon is 45, how many sides does it have? Well, we're talking about exterior angles, and each of the regular polygon is 45. How many sides? Well, first of all, what are we being asked for? How many sides? So sides is just going to be our n. How many sides, right? And what is our equation to find the exterior angle of a regular polygon? Well, 360 divided by the number of angles, or the number of sides, either one, right? So we've got 360 divided by, well, we're just going to have n for this one. We don't know how many sides. What does it equal? 45 degrees, right? 45 degrees per exterior angle. So now what do? Well, we cross multiply. N times 45, 1 times 360 here. And so we get our 1, take that over here, and times 360. We get our n, bring that over here, times, we'll do times here, 45. Right? And then so we get 360 equals n times 45. But remember, we're solving for n, we're not solving for 45. So we just divide both sides by 45. And we get equals n equals, what is 360 divided by 45? N equals 8. How many sides are we looking at? 8 sides. All right, let's look at the second page. Number 5 says, given a regular pentagon, penta, remember penta means 5, find the sum of exterior angles. All right, well remember, it doesn't matter what your exterior angles, how many sides you have for your polygon. If you're talking about exterior angles, we are talking about 360. Remember how when I shrank that polygon down, it formed just a little circle, and then all of those angles added up to a circle, 360. The measure of one exterior angle, well, that's just 360 divided by how many exterior angles you got. Remember, it's a pentagon, so it's got 1, 2, 3, 4, and 5. So 360 divided by 5, that is 72 degrees, so each of these little guys right there is 72 degrees. The measure of one interior angle. Aha, alright, so they're trying to trick us here. So if these two angles, remember your interior and your exterior, are supplementary. Those guys are supplementary. That means that they add up to 180 degrees. So, if we've got one that's 72 degrees, and we've got the total is 180 degrees, we have to figure out what is left for the other angle right here, right? Well, we just subtract that. 8, 0, 108. So this ends up being 108 degrees. That's the measure of one of the interior angles. And then the sum of the interior angles, remember that this is a regular pentagon. Well, what does it mean if it's a regular pentagon? It means that each of these interior angles are congruent. That means their measurements are equal, right? So if one of these guys is 108 degrees, then it's just 108. The sum of the entire interior angles is just 108 degrees. Oops. Times 5. And that ends up being 540 degrees, right? What is the other way that you could do that, you ask? Oh, well, I'll tell you. So if we know if it's a pentagon, we know that 180 times n minus 2 equals the sum of the interior angles, right? So we can just say, boom, 180 times, we said it's a pentagon, 5 minus 2. 5 minus 2 is 3. 180 times 3 is 540 degrees. There we go. All right. What did you notice about the measures of each exterior and interior angle? Well, they are congruent to each other, and the exterior and interior angles are supplementary. Now it's asking if each exterior angle of a regular polygon is 40 degrees, how many sides does it have? All right, well, we know the equation to find out one exterior angle, the measure of one exterior angle, right? It's just the sum of exterior angles. Well, that's always 360 divided by what? Well, it's the number of sides divided by the number of sides, right? And then that equals the one exterior angle. Well, in this case, they've already told us what that one exterior angle is, right? 40 degrees. So what are you going to put over here? You got it. Equals 40 degrees. And now, since we're cross-multiplying with this times this, the bottom times the top, and the bottom times the top, remember, whenever we have a variable in the denominator like this, we can just take that little sucker, move that over here. We can switch it with what's on the other side of the equals sign, and now we have, boom, that looks so much better. Well, what is 360 divided by 40? N equals 9. Right? Alright, that's the number of sides it has. Okay, I want you to try this one. What regular polygon has each interior angle measuring 140? Okay, so here's my hint to you. You have to figure out the equation that tells us the amount or the number of each interior angle. What equation do we use when we're talking about polygons to find the measure of each interior angle. Go ahead and you can look at your notes for that. And remember that you already know the measure of one of those interior angles. Pause it now and try it. Alright, I hope you had success on this one. For this, we've got to have 180 times how many sides? We don't know. N minus 2, right? But that gives us the sum of all of our interior angles, so we have to divide that by the number of sides to get us each interior angle. Equals, do we know the number of degrees in each interior angle? Yeah, we do. That is 140 degrees. So we're going to cross multiply this. We multiply each side really by n. We can see that this n and that n, they just cancel out. And so now I have 140n. Let's see. Oh, whoop. I'll go ahead and put this over here. Let's do 180 times n minus 2 equals 140n. So I'm going to distribute this n times these two guys right here. So I get 180n minus 360 equals 140n. I can subtract both sides, or subtract 140n from both sides, n, and I get 40n minus 360 equals, well, these guys cancel out, so that gives me 0. And I add 360 to both sides. 40n equals 360, and we are almost done trying to find out our number of sides here. 40n, of course, my two 40s, they cancel out, and I've got n equals 9. So we go back over here to where we started from. What regular polygon has each interior angle measuring 140? That's n equals 9. That's a nonagon. Oh, and you see what they did to me. Alright, nonagon first. You see what they did to me? They gave me something that had an exterior angle of 40 and an interior angle of 140, and they made me work all that stuff out. Well, if I had just been a little bit more observant, I would have realized that this regular polygon, its interior angle is supplementary to the figure that I had just found. 140 is supplementary to 40. And so, if those two angles are supplementary, they're the same, shape. Ah, Mr. Kelly. Oh, well. Okay. Number 8. If the sum of the measures of the interior angles of a convex polygon is 2,340, find the number of sides. Well, that's a whole bunch of angles. I mean, a whole bunch of degrees. Alright, let me clean this up here. Clean as you go. Alright. I've got my 2,340, and that's the sum of all my interior angles. So just to get that out of the way, I'm going to write 2,340 equals. Alright, well, I remember that the sum of all my interior angles is 180 times the number of sides minus 2 And then I can just solve for that. However, you know what? This time I'm not going to distribute, because that's just too much work. So instead of distributing, all I'm going to do is divide by 180 on both sides. Well, these cancel out, and I don't know what 2,340 divided by 180 is, so I'm just going to ask Siri, what is 2,340 divided by 180?
Let's see. The answer is 13.
The answer is 13. N equals 13. All right.